Okay, so in this video, I'll be discussing some of the tips and tricks regarding the question one, okay, that contain table and that contain graph, okay. So a lot of people are confused in significant figure decimal places, and they're mainly confused in the zeros, whether they are significant or not, and they're also confused in the instrument with their uncertainties, okay. So the expected instruments that are normally given to you will be the stopwatch, okay, stopwatch, and meter rule, okay, and the vernier caliper, okay, and protractor, okay, protractor, okay. So if you have any moving object, then always consider the uncertainty in your value from zero point 0.5, in between zero point 0.5 to 1 second, or you can go above 1, okay. You can take it in between zero point 0.5 to 1. Don't consider any value smaller than that, otherwise it could be problematic for you, because if the object is moving and you are taking the time, then the percentage uncertainty or the absolute uncertainty or the error in the measurement of time is would be larger, okay. And in meter rule, you consider the uncertainty as zero point 0.1, okay, 0 point, the absolute uncertainty, okay. So the basic rule in finding the absolute uncertainty is you just go to the instrument and see what's the least count, and you divide that by 2. That gives you the actual uncertainty, right? The actual error and uncertainty are both the same thing, okay. So but since if we have the meter rule, or if we have any measuring instrument like mainly meter rule and vernier caliper, we generally use zero point 0.1 centimeter as our error as well, and it is also the least count, right? And for the vernier caliper, it will going to be 0.01. If you want if you want to divide that by 2, 0.005, you can also do that. But it would be better to take this as your value, okay? It won't affect the answer, okay? Because the examiner doesn't specify a specific value. It leave up to you, okay? Whether which value of error you are considering in the exam, it will be visible, okay? Because you'll write the value in there, okay? And for the protector is 1 degree, okay. So these are 1 degree, you can take it as zero point 0.5, but just take 1 degree, because in most of the experiment, taking the uncertainty or taking the angle from the protector is quite difficult, okay. So we rather not take a zero point 0.5, we just take 1, okay. And always keep in mind that the uncertainty mainly depend upon the type of the experiment that you're doing, okay. If something is moving, that your uncertainty all going to increase, right? So it depends upon the scenario, fine. So these are something that you should keep in mind, okay. Now in question one, there will always be the part that ask you to set up the experiment at any specific position, and find a specific value of, let's say, time if you're doing oscillation, or let's say current if you're doing electricity, blah blah blah. So mainly in mechanics, if they have given you this type of question, so mainly they gave you 2 mark for that, okay? And for that type of question, they required the repetition, okay? So if you're finding the time, so you have to find the time for you have to find the time for 10 oscillation once, and then you have to repeat the experiment, okay? Because the repetition also contain a mark for that, okay? So then you have to take another time, okay? T2, okay, and then you have to take the average, okay, average in second, and then whatever the capital T will be, like you divide that by 10 to get the final form, okay. And like if you're getting, let's say, 10.2, okay, and let's say 10.4, so your average would be 10.3, 10.3. And since T is a absolute value, right, so you will write 1.03, right? Not in 2 dB, but in 3 dB. Okay. I'll explain later on what is the concept of dB, right? Okay. So this is a concept. Over here, you just need to show the repetition. Okay. So if you repeat the experiment twice for 10 oscillation, not for one oscillation, please. Okay. So if you repeat the experiment twice, then you'll get full mark. Okay. If you just do the experiment once, then you'll get 1 mark only. Okay. And now let's talk about the table. Okay. Table is basically very important and very key in your experiment in your question one. Okay. So please keep in mind, the table has a mark from 8 to 10 or 11. Okay. So these are like the total mark for the table. Okay. So here are some of the mark distribution. Okay. Let's assume that I have the table with me. Okay. And it contained, let's say, 4 quantity. I am assuming the quantities myself. Okay. It's not any specific paper. I'm just taking the values in order to help you understand. Okay. So, okay. Perfect. Okay. So please keep in mind that your table should contain all the quantity, okay, and then slash and unit, okay. This is very important, okay. Uh, and the second thing is all the quantity, okay, and then its unit, quantity and their unit, okay. Be very careful, okay. And if the quantity contain any power, the unit should carry the same power. Like if you have meter, if you have quantity, let's say distance under root, then your unit should also contain the same power of 1 over 2, right? If you have like L cube, right? Let's say L is a meter, then you have to take the meter as cubed as well. Okay. So be very careful, right? So unit and quantity both contain the same power and the unit. Okay. Fine. Now let's assume that we have a quantity. We have 4 quantities with us. So the first quantity is distance. Okay. Distance is, let's say I'm taking in meter. Okay. The second quantity is the the time for 10 oscillation. Okay. In second. And the third quantity is, let's say, capital T in seconds. Okay. And the fourth quantity is, let's say, D over, okay, sorry. I'm taking under root D over T. Okay. And the unit will going to be centimeter 1 over 2 to the power 1 over 2 and divided by second. Okay. Be very careful. Right. So they'll give you 1 mark on the column heading. Okay. Column heading with a proper unit will earn you 1 mark. Okay. So this is 1 mark. Right. Now, Acha, by the way, when you're starting this table part, always keep in mind that you should have to do the things in order. Okay, so just follow this order. Okay, first, first draw the table. Okay, draw the table. This is the first part, right? Now the second is um, fill the column heading. Okay, with units. This is the second thing. Okay. Now the third thing is um, fill the value of the quantity you are varying. Okay. Now the fourth thing is um, perform the experiment. Okay. And record the corresponding values. Okay. Corresponding values. Okay. Of measurement only. Okay. I'll explain. Okay. Don't worry. And then fifth, complete the table. Complete the remaining table. Okay. Now let's try to understand. Okay. Okay, so we did the first thing, we drew the table. Okay, this is the first step. Now the second step, fill the column heading with the unit. Okay, in every question they will mention which quantity they are interested in seeing them in the table. Okay, so you just read the question, and there will be like two to three quantities that were pointed out. So you just have to make sure that all of them should be in your table, right? And if you want any more quantities that are changing, that you can also include, right? Like let's say I have T1 and T2 and then T average. So if you want to include the T1 and T2 and T average as well, you can do that. If you only want to and if you only want to do T1 and and time for one oscillation, and this is also acceptable. If you also don't want to show this one and you are only showing that, then this is also acceptable. Okay, but for the safe side, just use this value, or just take a T1 and T2 as your value. Okay, and okay, so this is the second thing. Okay, so in drawing, after drawing the column, you first have to fill in the column heading, and you get all the column headings, all the quantities from the question. Okay, so once done, then the third step. Okay, please follow this pattern, otherwise you'll mess up, okay, in the paper, right? Please follow this pattern. Just step by step, one after another, will lead you to the very simple end, okay? So now the third thing is fill the value of the quantity that you are varying, okay? So over here, let's assume that I have the quantity D that I'm varying, okay? Let's say the distance of, let's say, pendulum, that I'm varying, okay? I have simple pendulum, hanging from the thread, okay, and I'm just changing its length, okay. So before starting the experiment, just fill in these values, okay, and then move on to this column, okay, before starting the experiment, okay. So, and the general rule is, if you have like whatever the thing provided, you have to take 75% or 80% as your range. Okay, so let's say I have the pendulum of the length 75 centimeter, right? The thread is of the 75 centimeter length. Okay, so let's just take the range as 60 centimeter, right? Which mean I have to vary the values that should be in the range of 60 centimeter, right? Like the first value and the second value and the last value, when you subtract them, so it should be like 60, or it should be like 55 or 60, around that. Okay, but don't pick too don't pick very small value, otherwise it will be very difficult for you to draw the graph for. Okay. So let's say I'm taking the value as um okay, 20, and okay, so in filling the column, I have some rules for you guys. Okay, so just note that down for. Okay, so in every column that you draw in question one, there are two type of columns in your table. Okay, so the first type is the one that contain all the measurements. Okay, these are the two column in which you will going to write all the measurement, right? Because the distance is something that you will be changing and measuring. Okay, the time is something that you are going to measure using the stopwatch. Okay, and I said, by the way, please keep in mind, this is just a general explanation. Okay, please do not relate it with any specific paper. I'm just making any specific case, any random case in my head. I'm just explaining. Okay, I just want you to understand the concept of plotting or making the table. Okay, yeah. So okay, so in every table you have two quantities, you have two type of thing. The first type of the quantities that are measurements. Okay, measurements, and the second type of the quantities are the calculation. Okay, calculation. Okay, guys, always keep in mind, when you have the measurement, okay, always keep in mind all the measurement should be written in the decimal places, and you should ignore the significant figures. Okay, look, so all the values down the column, down the column, okay? Column should be in DP, okay? Not ignore the SF, okay? Just ignore the SF for now, okay? SF for now. Just ignore it, okay? Down the column, every value should contain the same decimal place. Okay. Now the question arises where, who decide the decimal place? Whether to take 1 dp, whether to take 2 dp. How do we decide? Okay. So you just look at the instrument. Okay. Just look at the least count, and that will going to be your decimal place. Okay. Let's say if you have a meter rule. So the meter rule has a least count of zero point 0.1, okay, which means it can measure as accurate as or up to 1 decimal place, okay. So all the values that are taken from from the meter rule should always be in 1 dp, okay. Okay, so this column, the measurement column, contain all the quantities should be in 1 decimal place, okay. And if you're taking the measurement with the vernier caliper, let's say, so all you know that the vernier caliper can measure up to or accurate as 2 decimal place. Okay, accurately up to 2 decimal places. Okay, so if you're taking the measurement with the vernier caliper, then all the values down the column, okay, down the column should always be in 2 dps. Okay. So let me just write down the values for you guys. Okay. So I have this range. Okay. I'm just taking 4 values for now for the sake of understanding. Okay. So let's say the first value is let's say 20.0. Okay. Let me just write the column heading. Okay. D in centimeter. Okay. So the first value is 20. The second value is 30.0. Third value is 40.0, and the fourth value is 50.0. Okay. Look. Okay. Okay. Let me just show you one more thing. Let me just show you one more thing. Okay. Just consider 5.0, right? And then 8.0, and then 12.0, and then 15.0. Now, a lot of kids get confused. What is happening over here? We have 2 dp, over here we have two significant figures, and over here we have three significant figures. Oh shit, what should we do? So they just end up adding another zero. Okay, don't do that. Okay, the rule was you just need to fill in the column with the decimal place in your consideration. Ignore the significant figure. Okay, just ignore it. Contain 2sf, just ignore it. It contain 2sf, just ignore it. It contain 3sf, just ignore it. It contains 3sf, just ignore it. Okay, when you are doing measurement, you are not allowed to check the significant figure. You are allowed to see the decimal place. Okay, so these are the two values that are in 2 dps, and these are the two values in 3 dps. Okay, sorry, in 3sf. These are the two in 2sf, these are the two in 3sf. Okay, but for now just ignore it. Okay, you only have to see that these are all in 1 dp, and that is correct. Okay, so your first column is done. Okay, now so okay, by the way, I'm just writing down the values for the rules for the different columns. Okay, and then I'll start explaining. Okay, now again, since you are taking the distance from the meter rule, so you consider the decimal place of the meter rule. Okay, clear? And the same rule applies for another quantity. Okay, look, for another quantity. So I'm just copying it, pasting it right here. Okay, now the question arises whether the two column contain the same number of decimal place or the different. So just think about the instrument. Okay, the distance is taken from the meter rule, the time is taken from the stopwatch, right? And a stopwatch may have the different decimal places than the meter rule, or they both can be same, but it doesn't matter. Okay, if you have the two quantities and you measured from the different apparatus, then obviously they are not related in terms of decimal places, right? Is that clear, guys? So just keep in mind that. Okay, so this is the rule. Okay, so okay, by the way, there one more thing that I just want to Okay, just give me a second. Come on. Okay. So fine. Acha, by the way, if you have the distance, okay. So if you're measuring it in centimeter, right? So please keep in mind it will be in 1 dp, okay? 1 dp with meter rule with 1 dp if you're measuring it in centimeter, okay? In centimeter, okay? Just remember this, okay? And you have to write in 3 dp if you're measuring it in meters, okay? Is that clear? Right? So this is the concept. Okay, but if you're measuring it in centimeter, most of the experiment we did and we do in centimeter, okay? And in the question they will mention the quantity with the unit sometime, na? Or most of the time that measure this, okay, or approximately set up the apparatus at, let's say, 55 centimeters. So if they wrote 55 centimeter in the question, then you can use all the values in centimeter, okay? And if let's say they're saying 55 centimeter in the question, but let's say they're saying write that in meters, okay? Then you have to write that value in meter, but in the table you are allowed to go with the centimeter or with the meter, both are acceptable, okay? But uh to me, go with the centimeter, okay? It's like easy for you to write all the values, right? 3dp means like more things, and more thing means more chances of error, okay? Fine, just ignore it. Okay, so if you're measuring anything with a meter rule, then you have to write it in 1 dp, okay? If you're measuring it in centimeter, okay, and 3 dp in meter, okay? Now, as far as the time is concerned, okay, so you use a stopwatch, okay, and a stopwatch contain two decimal places, you know that, okay? That's like very known, okay? So, but in the exam, in the marking keys, in the examiner report, and in the list of the instrument that they provided us, um, they all in all the paper in the previous 20 years, they allow you to use a stopwatch that is as accurate as one decimal place or two decimal place. What does this mean? Like if you have the time value of, let's say, 12.47 second, okay? Let's say. So it's two decimal place, right? And this is what your digital stopwatch shows you, right? But the examiner gives you the choice whether to write like this when with 1 dp, or whether to write like this in 2 dp, okay? It's up to you. You have to decide which one to go with, okay? If you are going with 1 dp, you have to make sure that all the reading of time should be in 1 dp, okay? And if you are going with 2 dps, then you have to make sure that all the time should contain the two decimal place, okay? This is a simple thing, okay? But for me and for the student, 1 dp is like simpler than 2 dp, okay? But like if you're working with the 2 dps for the whole as, then just go with the 2 dps, it doesn't matter, okay? But be consistent with the decimal place in time, okay? Do not take 1 dp in some values and 2 dp in some values, okay? Is that clear? And you should remember that your all values should be in down the column should be in decimal places and not the significant figures, right? Let's say I'm getting the value of time, okay? Please keep in mind this order, okay? You first have to complete the table, then filling the column heading and units, okay? We did that. And now you have to fill the value that you were varying, okay? So I did that, right? Now I have to go to the experiment. I have to start performing, okay? So this is, let's say, T1, okay? I start performing the experiment now, okay? Because you know that you have to set up the thing, you have to set up the apparatus at this point, and then this point, and then this point, and then this point, right? But if you start the experiment without writing these values, so you will require more time in doing multitasking, which one to start with, and then what will be the next value, what will be the next value, and that will take a lot of your time, okay? So just go step by step, okay? So this is done. Then moved on to the second one. Let's say you are getting the time value as um, 9.4, okay, and then 10.2, okay, and then um 10 point, okay, 11.1, let's say 11.1, okay, and then 11.9, okay, 11.9. I just let's assume that I just perform the experiment. These are the values, these are the time values I'm getting, okay. Okay, again, just recall the rule. What was the rule? You just have to ignore all the significant figure, but your all value should be in one decimal place or in two decimal place, whatever you choose. Okay, I choose one decimal place. Okay, so but you can see that all of my values are in one decimal place. Okay, these are the two measurements, and all the measurements should be in one decimal place. Ignore the significant figure, please. Ignore the significant figure, ignore the significant figure, and ignore the significant figure. It is not required at this step, okay? Once you are done taking the measurement, now your experiment is done. Your experimentation, your performance is done. Okay. Just go through the values to ensure that the two values are not two values should not be alike. If the two values are like very close to each other, then just quickly perform the experiment for those two value. Okay. Because otherwise it will be like difficult for you to plot them on the graph. Okay. If you're not getting anything, if you're like if your result is like this, then it's very good. Okay. Clear? Okay. So now your experiment is done. Your measurements are take you measure you take the measurement. Okay. Now you have to move on to the calculation. Okay. Just do step by step. Do not go across the column. Okay. Just go down the column. Okay. For the measurement. Okay. Just go down the column when you're taking the measurement. Okay. Just go down the column. Please keep in mind. Just go down the column when you're taking the measurement. Right. So these are the two measuring quantity that we have, and now we are done with the measurement. You just place the apparatus, all the apparatus aside, just sit back and just start your calculation thing. Okay. Now, your experiment is done. Okay. Now, the second, okay. So this part is done. Okay. Okay, so this is done. Perform the experiment and record the corresponding value. Okay, so I perform at this and I record the corresponding value. I perform at this value of D and corresponding value of T is recorded, and then so and so. Okay, so this is all done. Okay, now the last thing, complete the remaining table. Okay, complete the remaining table mean you have the remaining values for the quantities that you have to calculate. Okay, yeah, now you have to complete those things, right? Now please keep in mind the rule is all the calculated value. Let me just write it down for you. Let me just change the color. So all the calculated value value of value of t should be in in same SF, meaning the significant figure, and ignore the DP. Right? Is that clear? Okay. Please keep in mind, once you are done taking the measurement, now you have nothing to do with the decimal place. Just ignore that. They're useless for you guys. Okay. So once you are done taking the measurement, just ignore that. They're the useless for you. Okay. Now, okay. Let's get back to this one. Okay. So I'm just writing down the rule and I just show you how to apply it. Okay. So, okay. Now, for okay. For T, you know that it is like one oscillation, okay? Acha, reminding you one more thing that while performing the measurement, you go down the column, okay? You go down the column. These are the two measurement, okay? Once you are done taking the measurement, now you don't have to go down the column, okay? Now you don't have to consider the decimal places, okay? These are the two things that you have to ignore it for now, okay? Now you have to go across the row and you have to ignore the decimal places. You have to consider the significant figures now. Okay, look, For the first quantity, the time is in two significant figure. Okay, so your capital T, when you divide that by 10, because we assume that this T1 is like time for one oscillation, so that would be 0.94. Okay, I just divide that by 10. Okay, 0.94. Okay, and if I divide that by 2, divide that by 10, I'll get decimal place shifted to the left. Okay, so that will be 1.02. Now most of the kid get confused. Okay, that this one is in two decimal place, and this one is in three significant figure, this one is in two significant figure, and they mess up, they just put the zero right here. Okay, please don't do that. Okay, examiner will not going to check the calculated value down the column. Okay, please keep in mind, examiner will going to check the calculated value across the row. Okay, since this is in two significant figure, this should also be in two significant figure, right? But this thing is not, does not have to do anything with this quantity. Okay, just ignore it. Okay, so this is in three significant figure, so this is also, or this should also be in three significant figure. Okay, so and this should also be in 3SF, and this should also be in 3SF. Okay, it should be zero point 0.9, not 1.9. Okay. Now, this is the calculation part. Okay. You're not doing any experiment, anything. Okay. You just doing the calculation thing. Okay. So, okay. So this part is also done. Okay. So you, for the measurement, you also always have to consider the significant figure of the quantity that is related with the measured quantity. Okay. So this quantity is related with the T1, which is the measured quantity. So you have to consider that. Okay. And you have to go across the row for all the values. Okay, and do not go down the column while considering the decimal, while considering the calculation. Okay, this contain 2SF. Okay, fine, no problem. This contain 3SF, no problem. This contains 3SF, no problem. This contains CSF, no problem, right? Also, we are not taking the decimal places into consideration for now. Okay, if they are taking all the values are in 2 dB, fine. Or if some in 3 dB or some in 2 dB, then okay, fine, no problem. Okay, okay, so this part is done now. The last part and the very important part. Okay. And okay, let me just take you to this portion. Okay. Wait. Mm, okay. Now, it's a very important thing. Please try to understand. Um, okay. So we have two cases right here. Okay. We have two cases right here. If you have, okay, if you have a quantity that is basically the product or the quotient of the two quantity, right? uh Two quantities, right? Then you have two possibilities. Okay, whether the two quantities both contain the same number of significant figure, whether the two quantities contain the different number of significant figure, right? So the first case is, if the two quantities, this is the first case, if the two quantities like d and under root d over t, if the two quantities are in the same SF. Okay, so um if under root d and t are both in same SF. Okay, then under root d over t should also be in in same SF. Okay, which mean which means, if you're getting the distance value in, let's say, 2 SF, and the time value in 2 SF, then your under root d over t will also going to be in 2 SF, right? If you're getting both the values in 3 SF, then your under root d over t is also be in 3 SF, right? But the problematic part is when you have one value and the higher significant figure and the other value in the lower significant figure. Okay, so if you have, the second case is, if you have okay, so if one quantity is with greater SF, okay, than the other one, the other one, okay, then we have this simple rule. Consider the significant figure in D over T as the lowest significant figure in the individual quantity. Okay, let me just write that down for you. So if one quantity is with a greater significant figure than the other quantity, then answer or D over T, okay, D over T should be in least significant figure. Okay, simple rule. These are the two conditions. Okay, and the both rule will be applied in the column right here. Okay, now let's try. Let me just have my calculator out. Okay, so okay, so the first value is, look, just try to understand. D over T, under root D over T is basically depending upon this value and this value. Okay, in the first part, both are 2SF. Okay, both are 2SF. So please don't get confused with these zeros, whether they are significant or not. I'm going to explain it after that. Okay, so this value and this value both are in 2SF, right? So the rule was very simple, that if you have the two quantities in the same significant figures, then this quantity will also be in the same significant figure. Okay, let me just do it for you. So under root 5 and over 0.94. Okay, so I'm getting 2.378759. Okay, but I did under root 5.0 divided by 0.94. Okay, so this is in 1SF, sorry, 2SF, 2SF, and this is in 2SF as well. Okay, so your answer should be in 2SF, right? So I round off my value in 2SF, so 2.4, and that's it. Okay, you have to put the units, centimeter to the power 1 over 2 divided by time. Okay, guys, that clear? This is the first rule. Okay, right? This is the first rule that we applied. If you have the two quantities containing the same number of significant figures, then your answer should going to be in the same number of significant figures. Okay, look at this quantity. Okay, so in the last part, both are in three significant figures. So your quantity should also be in three significant figure. Okay, let me do that for you. 15 divided by 1.19. Okay, so I'm getting the value as 3.254607. Okay, so I should write this as in 3D in 3SF. So that would be 3.25. Okay, that's it. Okay. So, and what was I doing is like 15 divided by 1.19, and this is in 3SF, and this is also in 3SF. Okay, so this one will also be in 3SF, right? This is a simple rule. Okay, now the problem is in the middle values. Okay, so, okay, this should also follow the same rule as this one, okay? Because this is also in 3SF, this is also in 3SF, so this value will also going to be in 3SF. So I'm not writing this one, okay? I'm just ignoring that one, okay? And I'm just solving it for this one, okay? So this column, this row contain the two quantities with a different number of significant figure. Okay, this one contain 2SF and this one contain 3SF. Right, now the second rule applies, and that was, if you have the two quantities with a different number of significant figure, then your answer should contain the least number of significant figure. Okay, so let me just do it for you. Under root 12 divided by 1.11, oh, 1.11, no, sorry, 1.02. Okay, so I'm getting the value of 3.396. Okay, so I just did 12. Sorry. It should be 8. It should be 8. Ah, okay. So I'm getting 2.77296. Okay, so 8 divided by 1.02. Okay, so this is in 3SF. Okay, let me just change the color. So this is in 2SF. 2SF. Okay, and this is in 3SF, right? The rule was if you have the two quantities with a different number of significant figure, just pick, just your answer should be in the least number of significant figure. That is 2. So you just round off round your answer. So that would be 2.8. Okay, is that clear? I wish so it should be clear. Okay. And if I just consider the last, if I just find out the last value, so that is 12 and it is 1.11. I'm getting 3.122. Okay, it's very simple. Both contain 3SF, so your answer should contain 3SF. Okay, 3.12. Okay. Now, please don't get confused that these two quantities contain 2SF, these two quantities contain 3SF. The examiner will not going to check your this column going downward. Okay, it will move like this. He will move like this. Okay, like this, and like this. Okay, so okay, I wish this thing should be done. It should be clear. Okay, so these are the simple rule. Okay, and their corresponding explanatory question is right here in front of you. Okay. Okay, so this part is done. Now, I was going to tell you the mark distribution, but it remains in the middle. Okay, so just understand the mark distribution. So the first mark was for the correct column heading with all the units. Okay, this is the first mark. Now the second mark is the range mark. Okay, so whatever, like how much you can or how far you can go or you can expand your experiment in order to take the values, that is your range. Okay, so let's say if they give us like 675 centimeter as like the total length of the pendulum, right? So your goal should be to use the maximum out of it. Okay, it's not necessary that you perform the experiment on 0 and 75. Okay, it's not possible, right? You cannot perform at the extreme values. Okay, and you are also you can also not be able to perform the experiment around the extreme values, right? You may not be able to perform the experiment at 74, 73, and 72, maybe 72, sorry, 72 and like that. Okay, so just consider 5 to 10 unit difference, okay, in the values. Okay, from both the extreme ends. Okay, like from 0 and from 75. Okay, so, okay, I wish that should be clear. Okay. So the second mark is the range mark. Okay. That this is the range for D. Okay. The first mark was a trend. The first mark was the column heading mark. The second mark is the range mark. The third mark is the trend mark. Okay. So look, you are increasing this value. Okay. So the value of T and the value of D over T should also follow some trend. Either it would be increasing trend or decreasing trend. Okay. So this is an increasing trend and this is also an increasing trend. Okay. If you're not getting the trend, like if there is some value that just breaking the trend, then you have to make sure you have to just readjust it to ensure that all the values should follow the trend. Okay, if you're not getting the trend, if you're not having the trend, then you have to make sure that like you have to adjust the value to make sure that it follows the trend. Okay, this is the third mark, the trend mark. Okay, the fourth mark is the consistency mark. Okay, consistency contain a lot of things. Okay, consistency contain the difference in these two quantities. This is the first thing, right? So every of your D should be approximately increasing with the same difference. Okay, like I use a difference of 3 in every next value. Okay, your value of D should be approximately up to the same or up to the same difference. Okay, approximately, not exactly but approximately. Okay, but try to go exactly if it's possible. Okay, so you can see that these are the difference is consistent. Okay, in every value, right? Now, the second consistency mark is that all of my D is 1 dp. Okay, I am consistent with the dp. Okay, I am consistent with the dp over here as well. Okay, I am consistent with the significant figures right here. Remember, we have to go across the column while taking the calculation. Okay, across the column. Okay, I am consistent. I am consistent with a significant figure going across the column, finding the final value. Okay, so this is like the consistency. Okay, and one mark, the fifth mark is for the sometimes the significant figures and the decimal places, okay, that you use the correct significant figure and the correct decimal places, okay. So consistency and significant figures are somewhat like overlap, okay. These are the 5 mark, and the remaining 5 mark will be given to you for just for putting the values in the table, okay. I wish so it should be clear, okay. Now one last thing or two last thing before ending the video. So the first thing is we have the zeros, and they're like very confusing while you writing it in significant figures, okay. So just understand some rule, okay. If you have We have three scenarios, okay. We have zeros that are non-significant figure, we have zeros that are significant figure, and we have zero that may be significant figure or maybe not, okay. We have the three condition, okay. So zeros can not be significant, not be significant, okay. Let me just help you out with a example, okay. So if I have 0 1 or 0 1 5, okay, like the way you used to write bearing values, okay. So you put 0 in front, okay. So that 0 is not significant, okay, it is not significant, okay, not significant, right. Okay, this is the first case. Now the second case is if you have this 0, if you have like 1 point, sorry, 0.1, okay, this 0 is also not significant, okay, not significant, okay. If you have 0.01, okay, this 0 is also not significant, okay, okay. And if you have okay, these are the three conditions, these are the three possibilities where we have the zeros that are non-significant, okay. And fine, okay, these are the three conditions. Now the other case is where we have the significant zeros, okay, where we have the significant zeros, okay, significant zeros, okay. So the significant zeros are like few, or actually more than that. So basically if you have 1.0, this 0 is significant, okay. Always keep in mind this 0 is significant, okay. If you have 1.01, this 0 is also significant, okay. Do not compare this 0 with the one you have right here, okay. These are the two different. If you have the 0 between the two non-significant number and the decimal, this is also considerable, okay. So this is also significant, okay. If you have the value like this 10.0, okay, let me just write that down. If you have the value of 10.01, so both the zeros are significant, okay, both the zeros are significant, okay. And this is also significant, okay. So both are significant, right. And if you're getting something 0 point, oh shits, just a second please. Okay, so if you have the 0 like this 0.104, okay, this 0 is also going to be significant, okay, significant, okay. And if you have the last, okay, the last kit, if you have um 0.10, this is also going to be significant, okay. And I think one more case, okay, let me just take you. So if I have 0.10, so this is also significant, okay. significant. And if I just have 10 point, or not 10 point, just 1 or 15.00, 15.00, so these values, these zeros are also significant. Okay. Okay. So if you just want to understand that how many significant figures are there, so for this one you have 2SF, for this one you have 1SF, for this one you have 1SF. Okay. Okay. And for this one you have 2SF, for this one you have 3SF, for this one you have 4SF, for this one you have 3SF, and for this one you have 2SF, for this one you have 4SF. Okay. These are all the significant figures, right? I wish it should be clear. And we have one more case where the zero can be significant or zero cannot be significant. Okay. So that case is if you have like 10. So this zero can be significant or it cannot be. Okay. Can be or cannot be. Okay. How? Or any zero like this. If you have like 1200, these two zero can be or cannot be. Okay. If you have like triple zero, these triple zero can be or cannot be, right? So it depends upon the table, the rest of the value. Let's say I am getting the value of 15, 25, and then 30, and then 45, let's say, right? So this zero will be considered significant because the rest of the values are into significant figure, right? And if let's say someone's getting the value of let's say 1300, 1350, okay, and then 1375, and then 1400, okay, and then 1425, okay, let's say, or let me take 1430, okay. Now you can see that this zero, the middle one will be considered significant because the rest of the values contain 3SF. Okay. Okay. So this is in 4SF. I have one value in 4SF. So all the zeros will be considered significant if I have the other value or any one value in the four significant figure. Okay. If I have this value, if this value would be zero, then these last zero would be considered non-significant and the middle one would be considered significant. Okay. So I wish the rule for the zero should be clear for you. Okay. So these are some zeros and you have to work accordingly. Okay. And this will be helpful in paper 2 as well. And it will be helpful in paper 4 as well in A2. Okay. And the rest of the subjects as well. Okay. And one last thing. And that is the final part after you drew the graph and you just have to. Okay. So who the hell is he? Okay. So you just have to. Fine. Mm, let me just open a question. Um, come on, one. Just give me a second, please. Merge. Okay, I have the question. Okay, look. So if let's say um the graph that you drew, the graph that you drew contain the x-axis. Let me just find out that. Okay, so plot the graph of cos theta on the y-axis. Okay, so cos theta on the y-axis. By the way, cos theta doesn't have any unit. Okay, so cos theta on the y-axis and t on the x-axis. Okay, let's say this is what you drew the graph and the line of best fit and blah blah blah. Okay, and this one is this. Okay, now the last part says that you have the equation cos theta equals to a minus bt. Okay, this part is the part where most of the student get confused. Okay, please keep in mind if you have the idea of y equals to mx plus c, mx plus c, then please keep in mind that whenever we are performing any experiment, we try to linearize the relation in order to understand whether it is valid or not. Okay, this is a simple concept, not related with the P3, but yes, it is related with the practical. Okay, so if you have the graph that is linear, And in most of the practical we have the linear graph. Okay, we don't have any curve in AS practical. Okay, so all the graphs are linear. Okay, so if it is linear, or if they are linear, so they should follow y equals to mx plus c, right? They will have some intercept, maybe positive, maybe negative, and they will have some gradient value and some x-axis value. Okay, so this part is basically what we call the concept of linearization. Okay, we have the the equation is linearized, we just need to compare it. Okay, so you just need to compare the value. Okay, so let's first just arrange it. Okay, so cos theta is equals to negative bt plus a. I can write this way. Okay, mathematically it's correct. Okay, why I am writing this way? Because when I compare it with y equals to mx plus c, now please look carefully. Okay, so cos theta is your y-axis. Okay, so cos theta is your y-axis. Okay, and you have the gradient equivalent to negative b. Okay, because your t is your x-axis, and that is like right here. Okay, that is like right here. So that's why I just move that way, move it in the beginning. Okay, and a is your y-intercept. Okay, because in the part in this part they are they're saying, right, put the value of find the value of a and b, right? So your negative b is basically equivalent to your gradient, so you just need to you just need to copy the value of the gradient from the previous part and just write that here, and that's it. Okay, but with a unit as well. Okay, so gradient mean you are dividing this and with that. Okay, because gradient mean change in y over change in x. Okay, so your change in y is basically cos theta. Okay, and theta is like in degrees. Okay, it has no unit, and divided by time in second. So your gradient will only have the unit per second, because this is in division. Okay, so it is in per second, right? So the unit will be second negative one. Okay, and for y-intercept, for okay, so c is basically your y-intercept. Sorry, a is basically your y-intercept. Okay, sorry, y-intercept. Okay, which is c, and y-intercept has a value of just y-intercept is basically having the unit of just theta. Okay, or just degrees. Okay, so just put the degrees on, or if you don't want to, just ignore it. Okay, so this is how you solve it. Okay, and by the way, please keep in mind, while calculating for the y-intercept, most of the students just take the y-intercept from the graph. Okay, don't do that. Okay, just because most of the time we consider the fake axis or the false origin. Okay, not starting from the zero. If you have the false origin, you are not allowed to take anything from the graph directly. You have to calculate for it. Okay, so you have to use y equals to mx plus c. You have to put in the value of the gradient. You have to consider any point and find and put in the values of in x and y, and that will give you your c. Okay, do not do not consider the value or read the value from the graph and just write it. Okay, this is incorrect thing. Okay, let me just do one or two thing, and then we'll be done. Okay, one or two equations, so that like it will be much clear. Okay, look, I have another question that contain the equation. Okay, so in the previous part you drew the graph that contain the x-axis. uh, okay, so plot the graph of t squared on the x-axis, on the y-axis. So t squared, second is squared, right? You have to mention the unit, and d in centimeters. Okay, yep, d in centimeter. Okay, so this is the part where you drew the graph. Okay, so now they're saying t squared is equals to ad plus b. Okay, this is a part, and they're saying you have to find out the value of a and b with the appropriate unit. Okay, now just compare it with the value. Okay, y equals to mx plus c. Okay, just look carefully that your y-axis contain t squared. Yes, it contain t squared. That's correct. Your x-axis contain d. Yes, your x-axis contain d. Yes. So the remaining thing would be the gradient, or the remaining thing would be equivalent to the gradient and equivalent to y-intercept, right? So your a will going to be your gradient. Okay, and your c will going to, sorry, your b will going to be your y-intercept. Okay, now let's talk about the units. Okay, so for gradient, you know that you do y over x, delta y over x. Okay, so to find the unit for the gradient, you also do y over x. Okay, so what is the unit for on y? That is second squared. And what's the unit on x? That is centimeter. Okay, just bring that up. You're not allowed to give that in the fraction form. So just write second squared and centimeter -1. Okay, and for the y-intercept, it is just passing through y. So that's why you have to consider the second square with as a unit for y-intercept. Okay, let's just do one last thing that is like quite difficult. Okay, so I have the graph drawn. Okay, so we drew the graph in the previous part, and that is of the quantity. Okay, so f on the y-axis in Newton probably. I think it should be okay, yes, Newton, and the graph of p plus r. Okay, p plus r in on the x-axis, and I wish p is also the distance, and r, where is r? It should be r should also be the distance. I wish so. Record the diameter. Okay, so it's also the distance. Okay, so please do not write the unit like this, 2 centimeter or centimeter square. It will just be centimeter. Okay, be careful. And okay, by the way, what we have to focus is the equation given as F is equals to W over Q times P plus R plus S over Q. Okay, please do not get confused with it. Okay, it's a difficult equation, but you just need to compare it. Don't worry. Okay, look. So if you have just write Y equals to mx plus c, right? So just look carefully that your y-axis contain 4s. Yes, your y-axis contain 4. Yes, this fulfills. Your x-axis contain p over p plus r. So this is also like that. Okay, so that's so the remaining thing would be equivalent to the remaining parts of the equation. Okay, so sorry, w over q is going to be your gradient. Okay, you just need to copy the value of the gradient from the previous part, and you just need to paste it. Okay, and S over Q is going to be your y-intercept. Okay, you just need to pick the value from the previous part, and you just have to paste it. Okay, once done, okay, so you should have the value of W. Okay, the value of W is given, by the way. Okay, you just need to find the value of Q and S. Okay, so you just need to find the value of Q and S. Okay, and S. Okay, that W is given. Okay, so if you make Q the subject, so it looks like this: gradient divided by W, and S, sorry, yes, S is equals to y-intercept times Q. Okay, now in this part, the unit is going to be like quite difficult, but let's try. Okay, so let's first figure out the unit for gradient. Okay, so gradient will be, you know that the gradient is change in y over change in x. So change in y contain the Newton, change in x contain the centimeter. Okay, so this is your gradient unit. Okay, so I'm putting the unit for the gradient, that is Newton per centimeter. Okay, and the W is also the weight of something, and it is also in Newton. Okay, it is also in Newton. Okay, you can just simplify it. Just okay, so that will be when you move that when you uh okay, 1 over n, your n and n goes off, and you will be left with per centimeter. Okay, just reciprocal it, and you just cancel it, and you will be left with per centimeter. Okay, and you have the for the y-intercept, sorry, for the S, the unit for the S, it is basically equivalent to y-intercept times the unit for the Q. Okay, so y-intercept is in Newton. Okay, so you have to put the newtons right here, and you have to put the value of Q right here. Okay, so that's it. Okay, so these are some part where most of the student get confused. Okay, so I try to make this video um in order to help you out in these many parts. Okay, so if you find interesting, then just leave the like, and if you have any question, then just text me in the comment section. If I'll be alive uh in the night, then I'll connect with you. Okay. Okay. Then take care, guys. Best of luck for your paper. Okay.